Okay, now we move on to piecewise defined functions. So what are these? Functions whose definition involve more than one formula are called as piecewise defined function. So you have more than one formula. For example, for this function fx, usually we only have one function, but now this fx, this function represent three different functions. So you have fx equal to 3 minus 2x, where x less than 1, and fx equal to 1 if x greater than or equal to 1 less than 2, and fx equal to 2x minus 3 if x greater than or equal to 2. So you have altogether three different functions. That's why it's called as piecewise defined function, because you have more than one formula. So when you have this type of functions, the graph look like this. So you have for this one 3 minus 2x, it is this one, this line, the decreasing line. For less than 1, this is 1, right? So the less than 1 will be this side. Okay, then you have fx equal to 1 for x greater than or equal to 1 less than 2. So you have from here equal to 1 until less than 2. Up until here you will have 1. It's a static. Okay, 1. Then you have 2x minus 3. So this one is increasing function, 2x minus 3, this one for x greater than or equal to 2. So it's this part. Okay, so this is piecewise defined functions. While this is absolute value function is like a modulus one, but with a piecewise defined function. So you have a combination of absolute value and also piecewise defined function. So we consider a function x over here, absolute value of x, where this absolute value of x represent x if x greater than or equal to 0, and negative x if x less than 0. So it's a combination of absolute value with a modulus over here and also a piecewise, because you have more than one functions. Thus, negative 3.1, absolute value of negative 3.1 is also equal to absolute value of 3.1, which is positive 3.1. So all of these things are actually the same. So the graph of this function shown as this. Okay, so you have like for x greater than or equal to 0, x greater than or equal to 0, you have this part, right? This part. When x less than 0, you have this part. It is decreasing, negative x. So this is actually the graph. Yeah, actually this one should be like this. This part, since you have negative, it should be like this. It was decreasing. So you have extra. But since this is a modulus, you have absolute value. So we don't consider this part. We just consider the positive one. Yang dekat atas saja yang kita tengok. Okay? So sama jugalah untuk yang ni. Then we have even functions. Function genap. Fungsi genap. If f negative x equal to fx for all x, then the graph is symmetric across the y-axis. Y-axis is when x equal to 0. This is y-axis. Okay, this is y-axis. So this is x-axis. So this is actually x equal to 0. Okay. So dia kata dekat sini, if you have a function yang mana negatif, sama juga function negatif ni, negative value of x akan sama juga dengan function positive value of x. That one we call as even function. Yang mana this one lah, rupa bentuk graph dia. And you will have symmetric across the y-axis. Symmetric mean when you fold a paper or a graph, you will have the same on the left hand side and also on the right hand side. Sama bentuk dia sebelah kiri dan juga sebelah kanan. That one is symmetric. Okay. So this is even function. Yang kalau negatif, this part, f equal to negative x, sama dengan f. This one is f equal to negative x. And this side, is actually f equal to x. Okay, so that one is even function. Like this. So you have sebelah sini f function of negative x. Over here you have function of x. Okay, this one is positive side, this one is negative side. But when you fold a paper, you get a symmetric. So that means that this one is even functions. And these are more examples of even function. How do you identify it is an even function? Is when you have a symmetric curve or you have symmetric graph. Bila you dapat symmetric curve atau symmetric graph, that means that one is even function. Okay, like this, the blue curve over here, sebelah kiri dan sebelah kanan sama. And the green curve over here, sebelah kiri dan sebelah kanan, kalau kita lipat dia, sama juga. And as well as this one, the red curve. Okay, so that are the examples for even functions. Let's see odd functions. So fungsi kita ada fungsi genap. Now we have fungsi ganjil pula. A graph can be symmetric about a point, called point symmetry. So previously untuk even function, dia punya graph symmetric about y-axis. Kan kalau yang ni kita tengok previously, this one is y-axis. Y-axis. Ini kalau even function. But now you have odd functions. So when you have odd function, dia symmetric about a point, dekat point, bukan dekat paksi, dia symmetric about a point. We call as point symmetry. So you will have like this, function of negative x equal to negative. Now the negative is outside. Negative fx for all x, then the graph is symmetric about the origin. Okay, dia punya keywords dekat sini is the origin. What does it mean by origin? Origin mean point 0, 0. This one is point origin. Over here is your origin. This is your y-axis. This is your x-axis. Okay. So dia symmetry dekat sini. Bukan lagi dekat paksi y. Okay, these are the other examples. So sama juga, it's symmetry on about this point, point origin 0, 0. Okay, these are more examples of odd function. So notice a symmetry about 0, 0. Where is 0, 0? It is over here. Okay, this is point 0, 0. So the graph is actually symmetry dekat 0, 0. Okay. Then we have simple rules here. When you have even function times even function, you will get also even function. Kalau you dapat nombor genap, fungsi genap, darab dengan fungsi genap, you akan dapat fungsi genap juga. But when you have odd function multiply with odd function, you will get even. And even times odd, we get odd. This actually similar, very similar with the one you multiply your negative number and positive number, right? So bila you multiply positive, you get positive. You multiply positive, negative, you get negative number. So the rules actually applied with this. It's quite similar. And for even, for this one is for multiplication, while this one is for addition, tambah, hasil tambah. So when you have even function, plus with even function, you will get even. Odd plus with odd, we get odd. Odd plus even, neither odd nor even. Okay, so can you prove this? Dia kata, bolehkah kita buktikan yang ni? So we see this example. Let's say you have a function g over here, gx equal to x cubed minus x. So when you have negative x there, so this whole thing over here, x, you will substitute it with negative x. So it's become negative x. This one also become negative x. So at the end, you get this value, right? So this is actually, this one and this one is actually quite the same when you take out the negative sign. So bila kita kumpulkan, kita keluarkan we extract the negative sign. So this is actually equal to this. This is actually equal, right? So that, what does it mean by all these rules, previous rules, okay? And let's see another example. Okay, therefore, dikata dekat situ, therefore gx is odd. Why? Because g negative x, the one we're given here, is actually equal to negative gx. This one is actually negative gx, right? You have gx. This is gx. This is gx over here. This is negative. So, bila yang ini, kita tengok balik odd function. The one with this. Ni, over here, dia punya rules dekat sini. Okay. Okay, how about this one? You have function of h equal to x squared plus 1. X squared plus 1. So you just substitute the negative x into this, then you get x squared plus 1. So it's actually the same with this one. So you'll get like hx is even function because h negative x actually you get the same hx. Okay, so this is odd, this is even. This is how you prove it. Okay, the last thing we need to learn about functions for this section is something about their domain. Okay, bila kita belajar tentang fungsi, function, you need to know domain. What is domain? And of course, we recall domain means set A, which is the set of value plug in for X. Maksudnya dekat situ, domain tu adalah satu set A yang mana value tu, all the values, you ganti masuk ke dalam X. Itu adalah domain. Ataupun sebelum ni kita belajar relation, domain is actually equal to input. Input mean X values, any X values. And okay, for the function, we will be dealing with, there are two illegals. Okay, untuk function yang kita belajar ni, dia ada dua illegals. Mean, there are two things that you cannot do. You are not allowed to do. The first one is you can't divide by 0. Denominator or the bottom of a fraction can't be 0. So when you have a fraction, bila you ada what is that? Pecahan, dia punya penyebut or the denominator cannot be 0. Tidak boleh 0. Okay? And you can't take the square root or even root of a negative number. Maksudnya dekat sini, bila ada square root, you tidak boleh ada negative 4 dekat situ. This one is wrong. Tidak boleh ada, you cannot have negative square root. Square root of negative number, okay? While for this one, you cannot divide by 0, means like you have 1 over 0. This is wrong. Definitely wrong. Okay? So, when you are asked to find the domain of a function, you can use any value for x as long as the value won't create an illegal situation. So, bila kita akan cari domain maksudnya input ataupun x values, you boleh choose any values as long as you tidak buat these two illegal thing ataupun ni dia punya rules lah yang you must follow. So this is actually the definition for domain. When you have domain, you will have range as well. Because domain is input, range is output. Okay. Given a function y equal to fx. So you have function fx, y equal to fx. So the domain of f is the set of all possible input values x. Dia kata possible input value x, any value, which yield an output. Yang mana bila nanti you ganti masuk this value, input dia ni, you akan menghasilkan satu output. And that output will call as range. The range of f is the corresponding set of output values y. Bila you dah ganti masuk set x ni, value x ni ke dalam satu function, you akan dapat jawapan. That jawapan is actually the range. Okay, this is actually how you show it using a graph. So you have x axis or the x values become your domain, and the one on your y-axis is actually your range. Okay, so this is a function y equal to fx, for example. Okay, the projection of y equal to fx on the x-axis is the set of allowable x values for f, and the projection of the y-axis is the set of corresponding y values. Maksudnya macam tadi lah, bila you have a function, this one, you substitute the value of x ke dalam that function, you will get a y value, which is, it become your range over here. Okay, for example, find the domain for the following function. So you have this function, 2x minus 1. Since no matter what value you choose for x, you won't be dividing by 0 or square rooting a negative number. So maksudnya kita tidak boleh divide dia dengan 0 ataupun square root dia dengan negative number. So the domain for this one, untuk x ni, untuk x, you can substitute any value for x. Okay, so the domain will be all real all real number x from negative infinity until infinity, which means that you boleh ganti masuk dia dengan negative 1, you boleh ganti masuk dia dengan 1, you boleh ganti masuk dia dengan 0, any number. So dia kata daripada negative infinity until infinity, as long as nanti jawapan dia bukan dalam bentuk pecahan yang 1 over 0 ataupun yang dalam bentuk square root negative 2, for example, any number lah, as long as dia bukan dalam bentuk yang ini. So bila you ganti negative 1 dalam sini, still you get 2 times negative 1, negative 2, negative 2 minus 1, you get negative 3. So it is acceptable, masih boleh diterima jawapan dia, as long as bukan dalam bentuk this one. Okay, so the domain is all real numbers of x. Daripada negative infinity until infinity, you can substitute it into the x, boleh ganti masuk dalam x. And how about this? Gx equal to x plus 3 divided by x minus 2. Okay, this is where you can apply the rules just now, the illegals. Dekat sini ada function, so ada pecahan, which mean that dekat bawah ni cannot equal to 0. The denominator cannot be equal to 0. Okay, if you choose x equal to 2, bila you ganti masuk x equal to 2, the denominator, which is this one, will be 2 minus 2, which is equal to 0. This is illegal because you can't divide by 0. Sebab nanti bila you ganti masuk dia ni equal to 2, you will get this one ganti masuk dengan 2, ganti masuk dengan 2, ni ganti masuk dengan 2. Dekat bawah ni akan jadi 0 kan? 2 minus 2, you get 0. So that one cannot. So we will say that the domain are all real numbers of x such that x2 tidak boleh equal to 2. Any number is acceptable except x equal to negative 2. Kenapa? X equal to negative 2 tidak boleh sebab nanti bila you ganti masuk dalam sini, the denominator become 0. So tidak boleh sudah. I hope you can understand that. Illegal, you see over here, it is illegal if this is 0. That's why you cannot substitute it with 2. Okay, dia kata there is nothing wrong with the top of 0. Kalau 0 dekat atas tidak ada masalah. Sebab 0 divide by any number, you will still get 0. But when dekat atas ni ada value, dekat bawah ni you divide by 0, you will get apa? Kalau you key in into calculator, you will get error. Okay, more example. Find the domain of the following function. Okay, I will see over here. So you have hx equal to square root x minus 4. Okay, this one involves square root. So we cannot this thing over here inside of the square root x minus 4 cannot be negative. So must be greater than or equal to 0. Maksudnya kita tidak boleh ada square root of negative numbers. Tidak boleh. Okay, di dalam ni tidak boleh ada negatif. So, kita kena pilih this x must be greater than or equal to 0. So, x, this whole thing must be greater than or equal to 0. So, x minus 4 greater than or equal to 0. X must be greater than or equal to 4. Ini dia just pindahkan saja. So, this 4 over here, you bring it on the other side. It's become x equal to, sorry, it's x equal to 4. That's why you get this thing. Okay, so now you can choose any value for your x as long as the x is greater than or equal to 4. We have to be careful what x we use so that the second illegal of square rooting a negative doesn't happen. This means that any number under the square root must be greater than or equal to 0. So kalau kita pilih 4 dekat sini, when you choose 4, 4 minus 4 still, if you, let's say h equal to 4. So you will get 4 minus 4, right? Which is actually equal to square root of 0. Square root of 0, you will still get 0. So this is still, you still have value over there. But when you choose this one less than 0, right? For example, x equal to 3, h equal to 3. So you will get 3 minus 4. What do you get? You get negative 1, right? You will get negative 1. You get negative 1. So this one cannot. This is wrong. This one is wrong. It must have positive value, or at least 0. Okay, more example. Find the domain and range for the following function. So you are given constant function where fx equal to 3, where x is element of real numbers. So x equal to 3 is actually a straight line, right? X equal to 3. This one is the straight line. Remember, this is fx is actually equal to y. So it's actually y equal to 3. So you get this one, y equal to 3. So the domain will be, domain tu maksudnya value on paksi x. So it can be any value from the paksi x. So this is actually the range, right? The one you get is actually, this one is actually the range. So the x value will become your domain. So your domain will be from negative infinity until infinity. It can be any numbers. And the range, okay, df is domain, rf is range of the function, which is 3. Remember, range is y-axis, the output. Okay, now you have linear function. Linear function with this function 2x plus 1. So when you sketch a graph like this, I hope you won't have any problem for sketching a graph. So we have this function, you just substitute any value for x. Let's say I start with negative 1, 0, and 1 so that I have 3 points on my graph. So this one, first, second, and third point. Okay, now you can see from the graph, why did I want to do graph? Why did I need to sketch a graph? Is because it is much more easier for you to see the range and the domain. Okay, otherwise, for those who are quite fast, they won't need to do this. They won't need to sketch a graph. From here, they can straight away get the answer. But for those who are a beginner or you want to see it clearly, it's no problem. It's not a problem for you to sketch a graph. Okay. So you have like this. This is straight line. Okay, this is straight line. So your domain from here until here, it can be from negative infinity until positive infinity. And also your range is paksi y kan? Paksi y. The graph can actually be continued from here somewhere dekat bawah ni. And it can also continue upwards. Mungkin dia sambung lagi dekat atas. So it can be, the range will be from negative infinity until positive infinity. So now you're going to use a formula to find range. That one is how you find domain and range from your graph. Now you're going to use a formula. These are the steps for finding the range. So there are 4 steps. The first one, you're going to find domain. So domain is your input or x values. The second one, you're going to let y equal to fx. So that's easier for you because y is actually the y values or the range Third one, you're going to solve the function for x in terms of y. And fourth one, find the values of y for which x is real in the domain of the function determined in step 1. So I think this is, you might be quite blur with this one. Let's see their example. Find range for the given function. This is the function given, x squared over x squared minus 4. So the first step is you need to find the domain, right? So you let fx equal to y. So now you're going to let this as y. Solve the function in terms of y. Find the value, blah, 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 blah. So this is actually how it goes. Fx equal to y. You samakan dia dengan y. This fx tukar dia sebagai y. So you get y equal to this thing. X squared over x squared minus 4. Now you can multiply. You can rearrange. Start rearrange. Bawa pindah. Bring this whole thing to the left hand side. You get this. So the remaining is only x squared. Now you can susun dia. Susun semula, rearrange up until you get this one. X squared equal to 4y, y minus 1. Since this is a square, you just want to find it in single x, in term of x. So this one, bila square ni kita bawa ke sebelah, it becomes square root. Square root of 4y, y minus 1. It's either plus or minus. You can get plus or minus answer over there. So from here, remember when you get square root, it must be greater than or equal to 0. Sebab kita kena follow the illegal side itu kan. We don't want to create illegal situation. So this thing inside the square root must be greater than or equal to 0. Kita tidak boleh ada negative number. Okay, so the range will become start from negative infinity until 0. Okay, dia kata until 0, close, and union will start with 1 until infinity. Not include 1, okay? Maksud dia close, this one is close bracket, maksud dia stop until 0. But this one must be greater than 1, not include 1. Kenapa? Sebab kalau you ganti 1 dalam sini, you will get 1 minus 1, this one become 0. So this one is illegal already. So you can be any value which is from negative infinity until 0, and then we stop until 0. We create another one. Union mean gabungan. Okay, dua-dua ni boleh. So you will start with 1, but not 1, not exactly 1. It must be greater than or equal to 1. Okay, so that one is the range.